So earlier in chapter 3, we had seen a couple quadratics that we said had no real solutions. And so that's what we're going to talk about today. They still have solutions, they're just not in the realm of real numbers. So we have what are called complex numbers or imaginary numbers to help us solve those equations. So we first want to start by talking about what's an imaginary number or an imaginary unit. We get an imaginary number when we take the square root of a negative number. So we call the square root of -1 I, which is this imaginary unit. So essentially all that happens is if I take the square root of, we'll say, -5, this isn't really considered simplified form. This negative needs to be removed from the radical as this imaginary unit I. So this would become I times the square root of +5. And the same thing is true if we have something that would simplify. So another example, say I had the square root of, we'll say -20. Well, I can simplify that 20 with a factor tree. So that's a 4 times 5. And then 4 is a perfect square. So I can take those pair of 2's out, but I also need to take this negative out and make it 2I times the square root of that leftover 5. And so one thing that we can kind of go from is if we go from I being equal to the square root of -1, if we were to square both sides of this equation, we get I squared equals -1. So we're going to start by just simplifying when we're dealing with this imaginary unit. So this first one here, this is similar to what I just showed on the last slide. We need to remove this negative from the radical and make this I times the square root of +3. Over here, it's a little different. We are squaring something. So we're going to square both of these items inside the parentheses. This is an I squared times the square root of 3 squared. Well, if I is the square root of -1, we've got square root of -1 times square root of -1, which is just equal to -1. So that I squared is -1, and then square root of 3 squared, that squared and square root are going to cancel, and I'm left with a 3. So -1 times 3 is going to be -3. And so essentially what this imaginary unit allows us to do is solve quadratics that don't have real solutions. They have imaginary solutions. And we would solve them in the same way as we solve other quadratic equations. So this quadratic equation here has only an x squared term. That means I'm going to solve by taking the square roots. So I'm going to isolate that x squared. I'm going to go ahead and subtract 15 from both sides. I have 2x squared equals -50. And then I'm going to divide by 2. So I've got x squared equals -25. And then I take the square root of both sides. So x equals square root of -25. I have to pull that I out. So I've got I times the square root of +25, which is 5. I also have to remember that when I take the square root, I get a positive and negative solution. So my solution here would be x equals plus or minus 5i. Or I could write it as the two separate solutions. So I could say x equals 5i and x equals -5i. So either this here or my set of solutions this way. We can also perform operations with complex numbers. So we can add them, subtract them, and then we can see multiplying and dividing in just a minute. If you are adding and subtracting complex numbers, you are really just combining like terms. So treat the I like it's a variable. So in this first example here, my 2 and my 7, I can combine to get 9. And then my 5i, I can combine with my -2i to get 3i. And that's it. That's my answer, 9 plus 3i. When you write your complex number, they are typically written in this form. So it's your real part, which is the 9, plus or minus your imaginary part, which is the part with the I. So over here, this next one, it's the same idea. It's just subtraction. Anytime you're subtracting a set of parentheses, I always recommend writing it as plus the opposite so that you carry that negative sign through. And then I combine. So I've got a 6 that I can combine with a -4. So it's a 2. I have a 3i that I can combine with an I. So it'll be a plus 4i. Multiplying complex numbers, this is pretty similar to just multiplication in general if you had an x for your variable, for example. So you're going to distribute. You're going to combine like terms. The only additional step is that you have to replace I squared with -1. So here I'm going to go ahead and distribute. I've got a 2 times -5, so that's a -10. 2 times 2i is going to be a 4i. I times -5 is -5i. And then I times 2i is plus 2i squared. So now I can combine my like terms. I've got a 4i and a -5i. So -10 minus 1i plus, I have to replace that I squared with -1. So plus 2 times -1. So this is -10 minus I minus 2. And now I have like terms that need to be combined again. I've got a -10 and a -2. That's a -12 minus I. When we divide with complex numbers, we need something that's called a complex conjugate. So this is similar to what we did with square roots, and we had to rationalize the denominator. We weren't able to leave those radicals in the denominator of a fraction. Same thing's true here. We need to eliminate the imaginary numbers in the denominator. So kind of like we multiplied by the conjugate to rationalize before, you're going to do the same thing here. So if you have a plus bi, the conjugate would be a minus bi. So you just switch that middle sign. Or if you had a minus bi, it would become a plus bi. And then you're going to end up multiplying by a form of 1. So whatever that conjugate is, you're going to multiply by it over itself. So here's an example. We've got 6 plus 4i over 2 plus I. Oops. Hang on just a second here. There we go. Okay, so you are not allowed to leave that 2 plus I in the denominator and have this be considered simplified. Again, similar to what we did if we had radicals in the denominator. So we need to multiply by the complex conjugate of this number down here. All you do is change that middle sign. So it's going to be a 2 minus I. We have to multiply by a form of 1. So whatever we're doing on the bottom, we have to do on the top as well. Then this really just turns into 2 multiplication problems. So we're going to distribute in the numerator. We've got 6 times 2, which is 12. 6 times -I, which is going to be a minus 6i. 4i times 2, which will be a plus 8i. And then 4i times -I, which will be minus 4i squared. In the denominator, we're going to do the same. So 2 times 2 is 4. 2 times -I is going to be minus 2i. I times 2 is going to be plus 2i. And then I times -I is going to be minus I squared. So then we're going to combine like terms in the numerator and replace the I squared with -1. We do the same thing in the denominator. So in the numerator, we've got 12. Combine the -6i and 8i to get plus 2i. And then it's a minus 4. Replace the I squared with -1. And then on the bottom, when we go to combine our like terms, negative 2i and positive 2i cancel. That's the purpose of multiplying by that complex conjugate. Those outside and inside terms should always eliminate each other. So we just have the 4 and then minus I squared, which is negative 1. So again, we just need to clean that up a little bit. We've got negative 4 times negative 1, so that's a positive 4, which can then get combined with that 12. So 12 plus 4 is 16, plus 2i. And then in the denominator, 4 minus negative 1 is really 4 plus 1, or 5. So 16 plus 2i over 5. So you have some textbook problems for your homework tonight, and then we'll do a little bit more practice with complex numbers tomorrow.